Alright, hello and welcome back. I'm on to question and video number 21 of this AP Physics C Mechanics multiple choice test. The problem today is a cannonball is shot from the top of a 30-meter high hill at a velocity of 25 meters per second and at an angle of 40 degrees above the horizontal and lands on the ground below. The speed of the cannonball at the top of its path is most nearly A, 0, B, 16 meters per second, C, 19 meters per second, D, 25 meters per second, or E, 29 meters per second. So to start off with this projectile motion problem, let's just draw a little diagram so we can better visualize what this is going to look like. So we have a 30-meter high hill. Let's just, bam, there's a little hill. Let's say this is 30 meters. Hopefully that's legible enough. So the cannonball is shot here at an angle of 40. Let's call this our 40-degree theta. It's shot, and then it comes and hits the ground over here. So what we want to know, this is 40 degrees is equal to theta. The initial velocity, so here we have V naught. Let me get a different pen with a smaller tip. V naught is equal to 25 meters per second. And what we want to know is the velocity at the top of its path, which is here. And again, this touches on a theme that was in one of the earlier problems we talked about. And I mentioned that the velocity in the y direction at the top of the path of a projectile going through projectile motion is going to be 0. Because since we have deacceleration due to gravity, with the gravity which is working in the y direction, obviously, it's the velocity, the y velocity, is going to be positive, positive, smaller, smaller, hit 0 for just a split second, an instantaneous amount of time, and then decrease, become more and more negative as this acceleration continues because of gravity, of course. So what we're looking at is the speed at the top of its path. We know that there's going to be no y velocity, but we have to take into account the x velocity. X velocity, so let's just write this down. So By equals 0 at top of path. That's point 1. Point 2 is that the x velocity is going to be constant throughout because there's no deacceleration or acceleration in the x direction. The only acceleration is gravity. So Bx is constant throughout. So now all that leaves left for us to do is solve for the velocity in the x direction for this system. The way that we're going to do that is we're given theta and we're given the initial velocity. So how we're going to solve this is we're going to say v initial x, which is the same as v for any x, but it's helpful to think of it as initial for now, is going to be equal to 25 times the cosine of theta, because the cosine of theta gives us this horizontal component. We don't care about the vertical component. We already know the vertical component is going to end at 0 at this highest point, but we want the horizontal component. So v naught x, which is the same as vx, is going to be 25 cosine 40. Whip out your calculators. I don't know that off the top of my head. Let's see. Got my trusty TI right here, 84. So 25 cosine 40. It's going to be about, oh, you cannot see, it's too dark. Well, 19.15 it says. I'm going to round it down to 19, and look at that. Perfect. 19. I say the most tricky answer to avoid here is the 0, because you might get the fact that Vy is equal to 0 at the top of the path confused with that just velocity itself is 0, but that is false because we also know that Vx is constant. So knowing that it's 19, we have an answer. Let me know if you have any questions about this problem, projectile motion in general. Yeah, thank you. Comment, let me know what you think. And our next video is going to be 22. Thank you for watching.